Renewable energy sources, harnessing the power of nature. Renewable energy sources, harnessing the power of nature. Introduction. In recent times, the world has been grappling with the challenges posed by climate change and the depletion of fossil fuel resources. As a result, there has been a growing interest in renewable energy. Why sources as a sustainable and cleaner alternative? Renewable energy sources harness the power of natural resources such as sunlight, wind, water, and geothermal heat to generate electricity or PRAVI. To heating and cooling. In this article, we will explore some of the key renewable energy sources and their potential to revolutionize our energy systems while mitigating the adverse effects of climate change. Solar energy. Solar energy, obtained from the direct or indirect sunlight, is one of the most abundant and widely available renewable energy sources on Earth. This energy can be converted into electricity through photovoltaic (PV) technology or used for heating and cooling purposes through solar thermal systems. The primary advantage of solar energy is its inexhaustible supply, making it a viable solution to meet the ever-increasing energy demands of the future. Furthermore, solar power systems have become more affordable, making it a popular choice in both developed and developing nations. Wind energy. Wind energy, harnessed by wind turbines, has been gaining momentum as a reliable and sustainable power source. Wind farms are installed in areas with consistent wind patterns, such as coastal regions or open plains. As the wind blows, it rotates the blades of the wind turbine, which in turn generates electricity. One of the significant advantages of wind energy is that it produces zero emissions during operation, making it environmentally friendly. However, its intermittent nature requires the integration of energy storage solutions like batteries to ensure a steady power supply. Hydropower. Hydropower, generated by the force of flowing or falling water, has been in use for centuries. It accounts for a significant portion of the world's renewable energy production. Large-scale hydropower. Plants operate by constructing dams to store water in reservoirs. When water is released, it passes through turbines, which generate electricity. Small-scale hydropower systems, such as run-of-river projects, require less infrastructure and can be implemented in remote locations. Besides electricity generation, hydropower facilities provide water for irrigation, flood control, and recreation. Geothermal energy. Geothermal energy taps into the heat stored beneath the Earth's surface. The heat comes from the natural decay of radioactive materials and residual heat from the formation of the planet. Geothermal power plants use steam or hot water reservoirs to drive turbines and generate electricity. This form of energy is reliable and predictable, making it an attractive option for both baseload electricity. Y generation and direct use applications such as heating and cooling buildings. However, geothermal resources are location dependent, limiting its potential in certain regions. Bioenergy. Bioenergy involves the use of organic materials, such as agricultural residues, forestry residues, and dedicated energy crops, to produce heat, electricity, and biofuels. Biomass can be burned direct. Converted into biogas through anaerobic digestion, or transformed into liquid transportation fuels. Bioenergy is a versatile renewable energy source, and with sustainable management of biomass sources, it can provide significant environmental benefits. However, there are concerns regarding land use competition between food production and energy crops, as well as environmental impacts caused by certain feedstocks. Nuclear energy. Nuclear energy is often a topic of debate when discussing renewable energy sources due to its controversial nature. While it is not a traditional renewable source, as it relies on uranium and plutonium, it is a low-carbon option. Nuclear power plants generate electricity through a process called nuclear fission, where atoms are split, releasing a tremendous amount of energy. The advantage of nuclear energy is that it can produce a significant amount of electricity from a small amount of fuel, making it highly efficient. However, concerns about the potential for accidents and the disposal of radioactive waste have led to a divided opinion on its long-term viability. Tidal energy. Tidal energy is another promising renewable energy source that harnesses the power of the ocean tides. By constructing barrages or tidal turbines, tidal energy can be converted into electricity. The rise and fall of the tides create a continuous and predictable source of power. Tidal energy has the advantage of being highly reliable, as tides are influenced by gravitational forces from the moon and sun. However, the high cost of infrastructure and potential environmental impacts on marine ecosystems pose challenges for widespread implementation. Wave energy. Wave energy, similar to tidal energy, utilizes the power of the ocean but focuses on capturing the energy in ocean waves. Wave energy converters can convert the motion of waves into electricity. This renewable source has the advantage of being available in many coastal areas with high wave energy potential. However, challenges in developing efficient and cost-effective wave energy technologies have limited its commercial viability. Hydrogen. While not an energy source itself, hydrogen has gained attention as a versatile energy carrier that can be produced using renewable sources. By using electricity from renewable sources to split water molecules through electrolysis, hydrogen gas can be produced. This hydrogen can then be used as a clean fuel for transportation or as a storage medium for intermittent renewable energy sources. How? Challenges related to hydrogen production, storage, and infrastructure development need to be overcome for widespread adoption. Exploring the potential of ocean thermal energy conversion. Ocean thermal energy conversion, OTEC, is an innovative technology that harnesses the temperature difference between warm surface water and cold deep water to generate electricity. It offers a promising avenue for renewable energy production. OTEC systems utilize the natural temperature gradient found in tropical and subtropical oceans to drive a heat engine, producing electricity in the process. This technology has the advantage of being continuous and highly predictable, as the temperature difference between the ocean layers remains relatively constant. The process of OTEC begins with warm surface water being pumped through a heat exchanger. This warm water vaporizes a working fluid, such as ammonia or a mixture of ammonia and water, creating high pressure vapor. The vapor then drives a turbine connected to a generator, producing electricity. After driving the turbine, the vapor is condensed using cold seawater pumped from the depths of the ocean. This cold water absorbs the heat from the vapor, converting it back into a liquid state. The cooled liquid is then recycled back to the heat exchanger to start the process again. There are two main types of OTEC systems, closed cycle and open cycle. Closed-cycle systems use a working fluid with a low boiling point, such as ammonia, to generate electricity. The working fluid I is contained within a closed loop, ensuring that it does not mix with the ocean water. Open-cycle systems, on the other hand, use seawater as the working fluid. This seawater is heated in a vacuum chamber to produce high-pressure steam, which drives a turbine. The exhaust steam is then condensed using cold seawater. OTEC holds immense potential for renewable energy generation, as the temperature difference between the surface water and deep water can be utilized around the clock. Moreover, OTEC systems have a minimal environmental impact, as they do not produce greenhouse gas emissions or require the consumption of any finite resources. They also have the potential to provide additional benefits, such as desalinating seawater and supporting aquaculture. However, there are several challenges that need to be addressed for widespread adoption of OTEC. The upfront costs of building OTEC facilities and the limited areas where the technology can be effective. If implemented are major barriers. Additionally, the infrastructure required for OTEC, such as long pipelines for cold seawater intake and warm water discharge, can be costly and challenging to